to welcome my latest distinguished panel, who have very gracefully devoted their time to this exhibition title, which is on, again, our theme is on evolution. And for our moderator, we are very lucky to have Yasmin Tayag. She's the copy editor of Nature Chemical Biology, The Last Magazine, and U+ magazine. She holds an M.S. In biology from New York University and an H.B. Science in English literature from the University of Toronto. She also occasionally writes and hosts videos for the Scientific American series Instant Egghead, and writes a blog covering everyday science in New York at scienceinthecitynyc.com, and I believe she's going to be writing on Scientific America about this.
I'm going to be writing about this event for the Scientific American S blog, because they are very interested in sci art, like all of us here. Yasmin, I am very thankful to our panelists who are joining us here today to discuss the art we have on display in our exhibition back there entitled Common Descent. So everything deals with our artists' interpretations of the theme of evolution. So I'm going to give you a bit of background on our panelists today. We've got right here on our left Giacomo Mancini, who is pursuing a PhD in Evolutionary and Developmental Biology at NYU. He received his B.S. in Biochemistry and Analytical Chemistry from Rutgers, and his thesis work focuses on changes in the brains of ants that undergo a transition from a non-reproductive worker to a reproductive queen-like caste, which he'll explain to us in more detail soon. In addition to being a lab rat, he enjoys playing the drums and performing woodwork.
Have some more for me.
Next to him, we've got Steve Bangs, who is an artist who has been featured at our exhibition, at our gallery here before. She investigates frontier science combined with symbolist figuration from an ecological feminist point of view. Her art has been included in 8 books and 2 peer-reviewed journal articles, several magazine articles, and art catalogs. Merging art and science, she worked for 3 summers as a NASA faculty fellow, very cool, and under a NASA grant, she investigated holographic interstellar probe message plaques, and she wrote Harvesting Space for a Greener Earth with Greg Matloff and her NASA colleague Les Johnson. We've got next to her Lynn Sures, who is a multidisciplinary artist working in drawing, printmaking, paper making, ceramic sculpture, and custom painting, artist books, and forged steel. Truly a multi-talented artist. And her recent book exhibitions include This Really Is My Thing in St. Paul, Minnesota, and De La Tierra at UNAM in Mexico City. She is a professor and the chair of the Department of Fine Arts at the Corcoran College of Art and Design in Washington, D.C. And she has been kind enough to join us all the way from Washington. And last but not least, we have Brent Wells, who is an evolutionary geneticist at New York University, studying principles that guide evolution to achieve similar developmental paradigms in geographically and temporally disparate species. The idea that certain modes of development are more desirable for life than others, and that evolution is able to improvise in order to find the sweet spots. Outside of the lab, Brent maintains a science blog at scienceunderthescope.com and enjoys cooking and making a little art of his own in the way of furniture. Very cool. He might be giving us some art by way of drawing. We'll see. Okay, so those are our panelists for today. And now I'm going to give a little spiel of my own. So, the image I have in the background of this slide is not something featured in our exhibition, but it's entitled Barcode Evolution by an artist named Richard George Davis. And the idea, this is one artist's interpretation of evolution. So we've all seen this sort of evolution of man, where we start with an ape, crouched over, slowly, work our way up. And Davis here sort of cynically envisions our future as regards humans as nothing more than numbers, barcodes. He thinks that we are just ultimately going to just be data. Thankfully, a lot of the art we have on display here does not take such a pessimistic view of our future, and we hope to explore that today. So, what is evolution? We throw around that word a lot. We talk about the evolution of ideas, the evolution of language, and of course the evolution of species. Broadly speaking, it's a term describing the process of change. And what's so interesting about art that's inspired by evolution, which is what has brought us all here today, is that it looks at how we've changed and how we might continue to change. And it links us to the ancestry of our species and highlights the factors that are influencing our evolution today. So, a bit of pop culture here for you. Does anyone remember Blinky, the fish on The Simpsons that grew a third eye because he grew up next to the Springfield nuclear power plant? Or take any of the mutant superheroes that have been around for decades. We have the X-Men, the Spider-Man, the Hulk. So, of course, these aren't actual scientific examples, but they're all inspired by the idea of species evolution, which is driven by genetic mutation, which our scientists today are going to talk about. And so though the artists behind these guys have taken some liberties, what they all illustrate is just how interested we've always kind of been in evolution. And of course, this is not a new interest of ours. We've been toying with the idea of evolution well before Darwin came out with this huge theory back in like 1859. For example, mermaids have been depicted in art since 1000 BC. And they are essentially humans that evolved fins instead of legs. And I think C's work has shown that. Or no, I'm so sorry. Not Suzanne Rees-Horvitz, who's featured in our exhibition. There's also the Greek, these are more mermaids. This is actually on display at the Met, I just discovered, and apparently is an inspiration for the Starbucks logo. It has been around for a long time. There's the Greek myth of Pegasus, which is a horse that they thought evolved wings. And even stereotypical depictions of angels in religious art show humans with the wings of birds. And these are, again, by no means correct or even possible interpretations of how evolution might work, but what they do is illustrate our belief or hope or even fears of what we might become or how we might change. So what we hope to achieve today is a discussion about how art can influence or clarify the way we look at evolution. And hopefully our scientists here can illuminate the aspects of evolution that we tend to get wrong. Because as you can see, we get it wrong all the time. And we also want to look at what evolution means in a much broader sense. And the questions that both science and art have the power to explore are, where did we come from and where are we going? So with that, I am very happy to introduce our first panelist, Giacomo Mancini.
So thank you so much for coming. I'm Giacomo. So I'm going to give a presentation. I'm going to try something I never tried before, which is present from the back. So if you can keep an eye on me and an eye on the screen, we'll be fine. No, if you have any questions, please ask me a question. So I'm going to, it was interesting trying to, because I always give scientific talks, but trying to give an art science talk is always fun. I had a hard time trying to juxtapose the two together. But what I'm going to give you is a background on evolution and art, and hopefully provide some sort of foundation for the night. And then Brent's going to expand upon that in his portion as well. So with that, let me go on the back over here. So yeah, that's me. Right. So I wanted to start off with a picture of the ant that I work on. It's called Harpagnathus saltator. It's from India. And this was the first depiction of this ant by William Morton Wheeler in the 1900s. So I should also mention a lot of this art that I'm going to be talking about tonight was done in the 1900s, 1850s, when we didn't have the luxury of microscopes and high-resolution photography. Well, we did have microscopes, but high-resolution digital microscopes. And basically everything had to be drawn by hand. It was a very intense work, and that's going to kind of be the basis of where I'm linking the art and evolution together, is making these these very precise drawings with some leeway to artist interpretation, but still keep it precise and keep it to the biology that was present at the time. So yeah, I'm going to jump back to this guy a little bit later on, but I wanted to start off with Ernst Haeckel. So this guy basically is the art biologist, right? So he was a naturalist. He went out to the field. He was a strong proponent of Darwin. And what he did, he went out in the field, collected samples, and he drew them. And that's what I'm showing on the right over here, which I think is his most beautiful drawing of radiolarans. And so he would organize his pictures in a way to show how similar organisms could be, getting to that point in evolution where we all come from a common ancestor, right? So that was his purpose here. And he did this back in the 1850s, and in the 1900s is when he published his book. And the whole idea here is, as scientists, we observe and we hypothesize. And that hasn't changed from in those times till today. This is what we do. So another point I wanted to touch on is Darwin's finches. And this is a famous drawing actually done not by Darwin, but by another evolutionary biologist called John Gould, who I have in the corner. And this story actually kind of coalesced his theory on evolution. So when Darwin was traveling through the Galapagos, through the archipelago, he collected bird samples. And he actually collected them from all these different islands, and he brought them back to Britain. And he forgot, where he collected them and where they were. To make a long story short, John Gould, who was an ornithologist, took these samples and noted where they were from. And what he discovered was they were all finches, and they were all finches actually from the main island. And what he ended up basically what he ended up proving was all these birds came from a common ancestor, from a common bird that was on the main island, and they evolved different beaks. So if you look at the two beaks on top, those are beaks meant for cracking nuts and seeds. And as it turns out, the main food source on the island where those birds were found were nuts and seeds. And then you have the birds 3 and 4 on the bottom. They're built more for insects. So as you would imagine, there are no nuts and seeds on those islands. So this was kind of the story that was popularized in literature and in science. And if you ever take an evolution class, this is one of the stories that's always told. And again, getting back to the art, getting to the very precise drawings, and being able to make comparisons and come up with different hypotheses. I want to jump back to Haeckel because another part of evolution is looking at development. As it turns out, you can kind of see where evolution has acted or is acting when you look at an organism develop, specifically animals. So I wanted to point. The first drawing is an early embryo of a human, a later embryo at stage 2, and then stage 3 is late when the baby is about ready to meet the world, right? So what Haeckel did was he would take embryos of different species and he'd draw them. So now I'm showing you a rabbit here. And something that you should obviously notice is that they're pretty similar, right? If you look at a calf, a pig, a chicken, a tortoise, and a salmon, and a fish, it turns out they're all very similar, right? So he made these really great drawings to pinpoint that you can not only look at evolution as it is in the world, but if you go back all the way to the embryo, you can also see it there. Now I should also mention, this is a little more of a nuanced kind of thing here, but he thought that, and it's funny, close but not right, that when you're an embryo, we as humans, we go through the different stages of evolution as we develop. So we go through a fish phase, a salamander phase, a tortoise phase, a chicken phase, a pig phase, until we get to the human phase, right? We trace back our ancestry through the development of our embryo, through development, right? So it turned out it wasn't exactly correct, but it was close enough. And it kind of, it solidified Darwin as not as a garbage junk theory, but as a real thing, right? So this is the ant that I work on, the jumping ant, and I don't want to spend too much time talking about my work because I wanted to point to something a little more, I don't know, I don't think people would ever notice that ants actually have a structure called a petiole, right? So if you look at any Hymenoptera, which is a wasp, bee or an ant, they all have this thing called a petiole, and it's evolved specifically for these insects. Why did it evolve? So they can do this. So they can basically sting their prey. They can take their abdomen, bend it back, and sting, in this case, a cricket. And this is what we feed them in the lab. We feed them crickets. And right, so this is why they evolved this thing called the petiole. Now, as it turns out, William Morton Wheeler and all these other myrmecologists, which is just a fancy word for an ant biologist, what they did is they drew all these different ants. And again, let's look at this Argentine ant, which is actually an invasive species that you can find here. And if you look at its petiole, it's different from Harpagnathus. And if you look at all different ant species, they all have different petioles, right? As it turns out, the design of the petiole is maintained within species, but not between species, okay? So if you look at all the different southern fire ants, all the different species that are in southern fire ants, they all have a very similar petiole. But if you look at a pavement ant, although similar, they are actually relatives, they're distant cousins, it's slightly different. They've actually evolved two petioles, right? And the order is house ant really doesn't have a petiole, carpenter ant, and so on and so forth. So again, coming back to the point of art and how important it was to science, and basically left us to where we are today. And I think that's the only thing I really have. All right, time for questions, or we'll save that for later?
Unless anyone has
Sure.
questions specifically
Let me talk.
pertaining to Giacomo's talk, we're going to save all of our questions for the discussion at the end.
Sure.
But I mean, honestly, if you want to interject, we will get that. Thank you.
Yes.
So next, yes, see, and you're going to have to.
I'm going up there. Thank you so much, and I will immediately go back and start reading the slides and check my notes with me. Yeah, I'm so glad that you put up the evolution of the ants and also the fish, the pig, the tortoise, and the human, because I'm going to be talking about our connection to the cosmos and the link between stellar and organic evolution. And I don't know if you've all been watching Cosmos, something happened, with the same excitement that Greg and I have, but it's been really exciting to watch Neil deGrasse Tyson talk about ideas that for me are what I got up in the morning for. So the last program, he talked about, and I'm just going to read some of this, the last night's installment, I'm reading from a science blog, was a great science history and science communication, and it wasn't until the very end that Tyson couldn't help but get all fuzzy and materialistic, which is where I live. He enthused our ancestors worshipped the sun, and they were far from foolish. It makes good sense to revere the sun and stars because we are their children. Okay, so this is a group of work that I did early on after my first summer at NASA, when I saw all these extraordinary pictures of the sun and the enormous sun flares and how truly extraordinary our star is. And it keeps jumping. I'm not sure why. So I did, which is actually in the back or in the front of the gallery. I think this is because I set this up as a slideshow. I did the Sun Beasts book, and it talks about how we all are, in fact, the children of the sun. This is the back of the Sun Beasts, where I'm using some of Greg's writing, talking about, so it is a program, right? Dragonfly. So as this runs through, this is still the Sun Beasts. The calcium in our bones and the iron in our blood were literally inside the stars that exploded in our galaxy before the sun was formed. In a sense, the stars helped form us and everything around us. In the architecture, and I would say in the body of planetary systems, one thing that happens, and this is what I have written, this is Greg's writing in the back of those panels. One of the things that is actually they found in planet formation, in star formation actually, is that it starts when the gas and dust swirls around what will become a star. So the planets are actually in the body of the star before it's formed, like the evolutionary images that we just saw. An exploding star lives on even though it dies, as we know now. Supernovas not only spew out matter that will eventually form other stars, but also the elements of life itself. The star's elemental ashes, silicon, oxygen, neon, carbon, and helium mix with interstellar gas and enrich the gas with heavy elements such as calcium and iron. So I'm going to make a jump now, and just interject another note. And part of these are all early works of mine, not so early, and this is the end of the show. So what I've done in addition to working with Greg, and I'm going to try to back this up, is I had a 13-year dialogue with a quantum physicist, Evan Harris Walker, who also was an artist, but he worked initially on the physics of consciousness, and I used his writing and his equations in my work with his permission because of the connection that I see between the cosmos and us and quantum physics and the way that Harris got me interested in what he was doing in quantum physics is I met him at a conference and he said, there is no such thing as space. And you can't really say that to an artist and have it make a lot of sense. So that started a 13-year dialogue on quantum physics and the nature of consciousness. And so I've included his work in with my work. And we dialogued through images and through quantum physics, and then I started working with Greg as I was saying to when I came in that when we went on our honeymoon we went to a conference. So that's sort of our life together. And by the way, what Greg has written on the back of the panels, or he didn't write them, I wrote it, but it's his words. It is therefore proposed that a field of proto-consciousness permeates the universe. Perhaps this field is identical to the dynamic vacuum. Consciousness of some sort is produced in those stars possessing molecules, since vacuum fluctuations play a major role, about 30%, in maintaining molecular bonds. One might wonder whether communication is possible between planetary and stellar conscious entities. Although, to be fair, a star's lifetime is so enormous compared to ours that it would be as if we were just blinking in and blinking out in the stars, from the star's point of view. So that's what I have.
Thank you. All right, next we've got Brent.
Okay. So I don't have any slides. I'm going to let you look at my name for a while.
Brent, do you want the lights on?
Yeah, that's fine. I might actually draw a bit though. But I want to start just by, I feel as one of two scientists here, I should really take a minute and give you the nitty-gritty of what evolution is. Yasmin sort of introduced it a little bit, and Giacomo gave us this nice tie between how scientists used to look at animals in the wild, naturalists, and draw them, and then take this big collection and start these comparative studies of them. But evolution, really Darwinian evolution, you know, this whole idea of survival of the fittest, when you get down to it, survival of the fittest basically means you need to be fit until you reproduce. So it doesn't mean it doesn't mean that you need to be powerful or strong or that you can fight off everything else. What it basically means is you need to be able to survive long enough to pass your genes on to the next generation. Because when it comes down to it, the way things evolve is through changes in the smallest units of life, which are DNA, right? Or maybe not the smallest units of life, but in the smallest code of life, which is DNA. And so evolution really is genetic variation, and when genetic variation becomes fixed in a trait like beak size or shape or something else like that that actually helps that organism perform better in the wild, then we see those traits fixed and the animals continue on looking like that. Evolution is often, we consider what an animal looks like, and that's, you know, that's what we see. So I look at the evolution of embryos in fruit flies and in a parasitoid wasp that is very tiny, even smaller than a fruit fly. And what I'm interested in is how these two embryos, how they actually go through development. They go through development very similarly, and yet they evolved along completely different lines temporally and geographically, meaning that evolution basically found a way to create something that works almost identically in two separate instances. That's okay. I'll try it upside down. So basically, and I'll try to raise it up here. So basically, what we have, if you can imagine, this is called convergent evolution. In order to do something, maybe it would make a little bit more sense. Say you've got a moth that likes to perch itself on a tree, and this tree has spots on it, like a spotted elm or something like this. If this moth is white, or maybe if it's all brown, then it's going to be pretty easy to be seen by an animal and plucked off here, and then it's dead. So it's not going to live to pass on its genetic code to the next generation. Now, say we've got, all of a sudden, one of these moths have a mutation. And that mutation, for some reason, causes it to have spots on it. Now this moth basically becomes invisible. It is generated a type of camouflage that makes it harder for predators to see. And so now this one's going to go on, and it's going to have, you know, moth babies. and then this one doesn't. So now we have a bunch more spotted moths, right? Okay, so now what I'm looking at is the fact that you have this moth doing this, and let's say now we have another one over here that does the same thing, but in between here we have a bunch of distance and time. And this means that evolution has basically come from some common ancestor, like Giacomo was talking about, and then managed along two separate paths, A and B, to change the genetic code to come up with the same outcome. And so that's what I started to look at. So when I change the genetic code, it's not necessarily going to be making the exact same mutations in different genetic pathways, but it's actually going to be doing it a different way and coming to the same conclusion. And that generally means that there are some principles in biology that are so advantageous that evolution is able to achieve it, even separated by distance and time. Specifically, I guess I never mentioned what exactly I look at. I said I look at the development of embryos, and there's one ways that insect embryos develop called long-term embryogenesis, where it basically embryos are divided into segments. Remember those pictures Giacomo showed of the embryos like this, and you can see all these, basically the vertebrae and the backbone. Well, that's called they're called somites and different segments of the body plan. Here, insect embryos do the same thing, where the body plan is divided up with these segments. And this is one way of doing it. This all happens at once, really quick. They go from an egg to a larvae in 24 hours. Another way of doing it, only a bit of the embryo is taken up by the actual developing animal, and then it has this long process of having to develop back. This takes about 5 days. So you can see how this would be beneficial. You don't exactly want to be out in the open with predators for 5 days with absolutely no defenses. You can't move, you're trapped in an egg. And if you can bring that down to 24 hours and get somewhere where you're not as easy to find and you're mobile, then it could definitely be beneficial. So that's basically what I had to say, but do you want to work with me on?
Sure.
So we also, Giacomo and I, we thought we'd give a little interpretation of our own on some of the work here. Being scientists that really don't think about this stuff too often. We can bring the lights back down. Okay. So Giacomo?
Yeah, so one of the things Brent and I, we decided to come down here a couple weeks ago. I have no sense of time right now. And we were just looking at some of the pieces, and one of the things I was doing when I was going through all these pieces was what were the first thoughts that were coming through my head. And it's hard because when you're a scientist, you think of things in black and white, and there's only absolutes. There's no grays, right? Even though a lot of our research is gray a lot of the time. But I mean, when I was looking at this work by Lynn, I actually spent more time concentrating on the canvas that it was drawn on, trying to make it look like stone, and why was it sparkling, why was it going through all like, then looking at the actual skull, and then taking a step back, I noticed the skull and the colors that were on it, and the way I thought of it was, that the skull was trying to, put some life into the skull by giving it some color, because if you look at all, the artifacts and fossils that are around, they're not colorful. So that was my thing. Okay.
This one, I like this one a lot, just because basically evolution is a real trial and error process. For everything that exists today, it's gone through a bunch of intermediates, and so this is basically, it looks to me like a bunch of intermediates that have come together into what we are today. So I thought that was pretty cool.
And Lynn can tell us if we're right or wrong.
Yeah.
I cannot wait for my chance.
Or should This is one that I liked. Basically, for what I just said, evolution for the one organism that becomes fit because of a mutation and lives. There's thousands that have a mutation that is actually detrimental and it dies. And so a vulture, something that preys on dead things, I thought was sort of cool in that sense. The other thing is the body of this sort of reminded me of a shrub or some sort of bush. And I thought that, that's interesting because animals and plants absolutely have to evolve together. As an animal might evolve a way to eat a bush that's normally poisonous, then the bush has to evolve to become more poisonous, or whatever that intersection. Also, the body, as far as I can tell, we were looking pretty closely at it. It looks like it's out of an old dictionary paper. And I thought that was interesting because, a dictionary, there's many different, as synonyms go, this reminded me of my work, there's many different ways to make a sentence out of the same sentence that means the same thing out of different words, and there's many different ways to come to the same evolutionary outcome using different gene pathways and stuff, so I thought that was kind of
Yeah, so this was some C. Bang's work, which is on display in the back, and Brent and I were basically going over this, and so this is basically, if you wanted to know anything about evolution in an artistic sense, this is probably the art piece that you want to check out, because it gives a nice interpretation and description of the early hominids and how they evolved over time. And when Brent and I were going over this, we thought it was cool that there was a picture of showing these two early humans walking hand in hand outside of the Earth. And a lot of the things that I guess people that think about evolution don't realize, it's not just at the genetic level where evolution happens, it's also the environment, right? As Brent was talking about time and distance and the trees, for instance, right? That's the environment that we're talking about. So basically juxtaposing evolution, space and time, and that's the way I saw it in terms of, giving us the environment's effects on the pathways of evolution.
Yeah. Okay, and this jumpsuit I thought was really cool. So I don't know, you can see it here behind you when you leave, but it has chromosomes all over it. And similar to what Giacomo just said, I thought it sort of speaks to the fact, I mean, in this case, you're wearing your chromosomes on the outside of your body, your DNA, and it speaks to how susceptible evolution is to the outside environment. In fact, it's completely susceptible to the outside environment. And this is sort of a very literal interpretation of exposing your DNA to the environment. And also, it's kind of cool because the material is very, very, very thin, and I think that's cool because it talks about actually how very slight changes can affect our DNA. Even a difference in temperature of 1.5 degrees basically is why we don't have giant lizards roaming the earth, and we instead have large mammals roaming the earth.
The other thing I was talking to Brent when we came here that Friday, I think it was, is that we should get some of these worm in the lab, because I think it'd be like, it's a mechanic suit doing work like that.
It's also good.
Yeah, absolutely. So Yasmin stole a little bit of my thunder with this, whenever a lot of it of my thunder. It's okay. But yeah, so I mean, when I saw this picture, I knew it was going to be, in reference to evolution, and that was going to be the backdrop here. I mean, a lot of people think, when you look at art, it's very fantastical or it's imaginative, and there's no solid basis to it. But because we're talking about evolution, mermen are completely possible, right? If we had a fish that was in a swamp at the right time in the right place and got the right mutation, the environment was just right, we could have evolved mermen. Even mermaids too, right? I mean, we could have had a whole system. We all could have fins. I mean, it just depends on evolution. It's a huge lottery, evolution. I mean, that's what you really come to find out about it. And the more you learn and the more you go through it, it's amazing how the years that go into making a merman or something along those lines, and how everything has to happen just the right time, just the right place for things to happen. I think that's where a lot of people get their mind blown. I think that it can't possibly happen because everything has got to be so perfect. But we're talking about millions and millions and millions and millions and millions of years for all these things to happen. So this is possible. This could happen. And this was, I just thought this was an awesome piece, just because it says winner on it. No, I mean, actually the one thing I noticed that I like the best here is that whoever this person is with this awesome beard was shown, so she has the chromosomes going behind him and in front of him to sort of, I'm assuming he discovered something with the chromosomes, that's to put him inside the chromosomes itself, part of the discovery. And that is like way out there, but I mean that was actually the first thing I thought of when I saw this piece, and I just thought it was really fun to put it up here.
Yeah. We always talk about winning the genetic lottery.
Yeah.
There's no real winning in evolution, and we'll get to that later. I want to talk about whether there's an actual evolutionary peak.
Sure.
Which is a no. Okay, we'll have our last panelist up now, Lynn.
Hi everybody, I'm Lynn Sures. I just wanted to thank you for coming tonight to our panel, and I'll go back there. Sorry. So, just to, I'm really thinking so much about what you all were saying about those two pieces. So, all right, first of all, I make my own paper. So the pieces in the gallery that you see, I made all the paper for those pieces. So that's the substrate. So this is a really, really early example of making paper and being interested in evolution and sort of putting something together. So I am an artist, I'm not a scientist, and I think about things. So I went to the library and I got out books that had black and white photos of hominid skulls, and I read the things about the skulls, and I thought, it's really interesting stuff, and I started drawing from the books, from the photos in the books, and then I started thinking, well, I'll make Africa, and I'll put some of these skulls I've been drawing into this piece. So that piece on the left is like about a 6-foot high piece of paper that's lumpy with texture, and then the detail on the right shows you one of the skulls, what it looks like, because paper is fiber and it's made of all these little colored bits that web together, and so that's the first one. And then I was learning things about fibers, and I found out that you could use flax and make paper pulp out of it. So I made up some flax paper pulp, and I looked up what the Olduvai Gorge looked like, and so I made Olduvai Gorge on the right, and I made the Africa with the flax fetus that looked kind of mummified the way I made it, and I thought, well, you know, I'm just talking about how these things happened a long time ago, and we're learning about them now. Again, this is about 6 feet wide, and it's one piece of paper, and it's not a painting, but all the colors you see are liquid paper pulp that I've colored in liquid state and fashioned together to make that sheet of paper. So here's one. Lucy caught my eye, and so I made one of these in 1996. No, earlier than that, a little bit earlier. And it was on this magazine about hand paper making, called Hand Paper Making Magazine. And all right, so I continued working in this, with this interest of hominid skulls, but also in general evolution. And so you can see in this piece here, first of all, I made the edges very irregular. Second of all, I referenced a whole lot of different things that I, in my totally non-science educated self, remembered of our evolutionary history as humans. Well, there were cave paintings, and well, there was the Venus of Willendorf, and then I knew there were these footprints that had been found in Africa that dated back to a volcanic eruption back when people didn't look like those of us in this room. And I made a Brazilian Indian, and I made a Mayan sculpture, and I just put it all together, and I called it Human Frieze. And then I made another kind of tribute to a Neanderthal skull that I read about called La Pharisee. And I mean, I can't tell you anything about these names. I mean, I'm just presuming that that skull was found at La Pharisee, wherever that might be. But I do know it's Neanderthal, and I knew I found a couple of views, and I found a picture of a hand, and so this is what came out. All of these are very, very large pieces of paper, much bigger than what that looks like on the wall right now. And the world tree, which again follows that same kind of reasoning of putting together different cultural references from a very, very long time back through maybe more contemporary times. Then I did this etching about Homo erectus, and I mean, I don't know if Homo erectus is us or not, but I titled it It's Homo erectus, It's You, because I thought, you know, the whole curiosity I have about all of these hominids through my total fascination with what their skulls look like is that they all are somehow contribute to us having come about. And so I did this etching, which is a very tiny piece. It's probably about 8 by 8 inches. And Rick Potts, R. Potts, wrote a book called Humanity's Descent. Rick Potts is the director of the Human Origins program at the Smithsonian Museum of Natural History in DC. And more on that later, unless you've already read the article that I wrote in the magazine that Maddie showed you earlier. But I did get to know Rick Potts, and he used this as the frontispiece in that book, Humanity's Descent. So I started going down to the Smithsonian to draw hominid skulls because I decided that my black and white Xeroxed reproductions from the books I was getting out of the library weren't as fulfilling as, you know, they could be. So I would go down to the museum, and I would bring some of my handmade paper, and I would draw out the skulls, and I got drawings done of the few that they had on view, and then I met through a some lucky happenstance, some of the people up in the Human Origins office, and then continued going to their office on a nearly weekly basis and drawing hominid skulls on this paper that I would bring. And so I would bring some paper and some colored pencils and sit there at my own little desk in the Human Origins office with a skull sitting next to me, and I would just, you know, stare and draw without speaking to anyone for, I guess, a day. And it was fabulous. And the paper is made to emulate a substrate that something might be found in. So you can make paper any way you want to, and that was something I knew how to do. So it worked. And so the other thing about making your own paper is, if you already have a piece of paper that looks like these pieces of paper, then it's kind of like you almost have your drawing started already before you start. And so there's nothing scary about putting the first mark down on the paper and just getting down to business. So I got to know all these individuals through spending so much time with them and staring at them and understanding what their forms and contours were, and it was just so fabulously interesting. And the colors are the right colors. I didn't make them up. So I don't know what else to say about that. They weren't the real, I mean, probably their actual skulls didn't look like that when they were in their heads. But by the time we got to the table with me and all of the different bouncing light molecules and everything, particles I mean, and things that happen in the world, I think I got the colors right there.
I hope my skull looks like that.
Me too, because now see, this one doesn't have those same colors because it didn't look that way. So I don't know why. And that was an interesting point. I was super thrilled that you said that, because I realized, whoa, the things that are so obvious to one when one's working don't necessarily transmit to anyone else. So thanks for giving me the opportunity to go into that. So then these are the ones that are here in the show. And that particular paper on the left is made out of hemp fiber. And that's what helped it to come out so incredibly gnarly like that, which is just a great, good fortune, I thought. The one on the right is made out of flax. And the one on the left is made out of linen, and the one on the right is made out of a different linen and flax combo. And they're all done with colored pencil. And all the paper is 18 inches high, 12 inches wide when it starts, but some of the paper is processed in a way that makes it shrink up a bit and get irregular, and others are made in other pulps are beaten in such a way that they don't tend to shrink or distort so much as they dry. There's not as much internal tension in the fibers, so they just are the way they are. So then I started making more big paintings, but I had done these drawings and I felt like I knew the individuals a lot better. So I went back to these 6-foot high pieces of paper, but this time I felt like I was not only making the skulls, but I was also really making the substrates, and I was learning how to work with paper pulp in a different way. So hopefully that is coming across a little bit. You can see the detail. I was working it pretty much exactly how I intended, instead of a lot of things happening by chance. So the detail is on the left, I guess you can tell. This one was one of the hardest pieces I've ever made, was to weave that Turkana boy skeleton into the midst of all of the skulls and have it be there but not be there in a way, kind of musically. And then I learned how to paint with oxides on tile in a Maiolica style. So I thought, well, what can I paint? So I painted these 6 portraits. small. I think they are like maybe 6 by 6 inches tall. So, and I also learned at a similar time how to make, how to throw my own tiles and create a relief in them. So I was making some things, some of the individuals, I have a portrait both in the top, the prefab myolithic tile and in my own relief tile. So I made a couple of comparison slides for you all to see how they might look, different interpretations. So I'm kind of like revisiting some of these skulls that I've already done, but just in another medium. And then I made the rubber stamp from my drawings, and I think that what you said was probably right. I mean, I don't think I could say it, but it sounded good. And then I'm going to end up just talking for a minute about the book, the variations on the dialectic between Mingus and Pithecanthropus erectus, which was a complete fluke in that I happened to hear the music while I was sitting at a metro station listening to the radio waiting to pick somebody up, and it was identified, and that caught my attention right away. And so I called my, at that point, friend Rick Potts and said, hey, I just heard this music, and he said, oh, that sounds like something we could work with on that project that we keep saying we're gonna do, which we haven't articulated what it is. So we did it, and it took us about 5 years. And so this is a woodcut. All of the images on the Mingus book are woodcuts that I drew the Mingus portraits from looking at pictures, and those are the same footprints that you saw in one of the images I showed you earlier. And the whole book is just a whole story of kind of evolution from Pithecanthropus erectus, indirectly, directly, whatever, and through to our contemporary selves and maybe Mingus specifically. This is one of the incidents that's kind of alluded to in the book, was that the skull and femur of the Pithecanthropus erectus was hidden for some period of time by the discoverer under his floorboards, salute, because he wasn't convinced that it would be understood what he had really found. So there's the book, and again, the color in the book, and you can, if you look at it on your way out, you'll see that it's colored paper pulp, just like those paintings that I showed you earlier on. I think that's my last slide. Yep.
Thank you. Now, a question for you, actually, I've been wondering this. How did you decide, like you go through all of these steps in hominid evolution, how do you decide when to stop?
Like me?
Yeah. Because you come through so many species, but like we're what, Homo sapiens sapiens.
Yeah. I think I just look at everything that I can and say, like, there's more to do, but it's not looking forward, it's just that they had to discover more things, and that they have. So I have more work to do.
Well, that sort of leads to the first question I had is, I've noticed that so much of the art that we looked at today, it deals with largely our evolutionary past. Of course, the skulls that you looked at, and even our embryological development, that is sort of looking backward. But what's interesting is that we don't often see too much about our evolutionary future, and maybe we're a little bit afraid to. conjecture, to even guess what that might lead to. I'm gonna open this one up to the scientists at first. Do you think it's dangerous for us to do that? What if we get the factors wrong? How would we even, it might just be misleading if we guess what we might evolve into. We have actually one of the pieces on display right out here is by Daniel Lee. It's called Self-Portrait. And I don't know if you noticed it when you came in, the artist took his actual photograph and sort of imagined his own evolution from, a more ape-like form into his present self and into a sort of post-human, something that looks like it came out of Avatar or something. Is it dangerous to do that? What?
I mean, I think people have conjectured about, and I think this is basically it, right? People think that maybe the next step in evolution is some sort of alien that we develop some sort of telekinetic powers and communicate with some big social organism or something. But as far as danger, I think it would only be dangerous if there wasn't laws set in place to keep us from genetically driving it that way. I mean, you can think about a situation like in World War II, where you've got something like eugenics and a few crazy people decide that they're going to actually try to genetically select for a certain type of person and move humanity forward in that way, but it's just not going to happen. And so I really don't think there's any harm in having fun with it. Yeah.
Can I jump in?
Yeah.
When we go into space, if we don't figure out what could happen genetically, then we will be really sort of causing ourselves to de-evolve very quickly, because the factors of what happens in space are so extreme, even in a short amount of time, that we really do have to figure out how to work with those ideas and to biologically work with the fact that we lose calcium at an alarming rate. The heart becomes round instead of its normal shape. All sorts of things are going to happen when we go into space and become spacefaring, hopefully, species.
Yeah, I think just one of the points that I want to make really quick to jump on Brett and also C's point is that, I mean, evolution is happening now. It's happening as we speak. We won't be around to see it. It's going to happen millions of years later. And that's why, our progeny, the children that we have, that evolution is, basically our evolution is going to be happening on them. Let's say, I have a kid that has, really big muscles, right? So he's going to be great at chopping wood. And let's say, something goes wrong where we have to chop wood. He's going to be favorable and he's going to be able to chop wood, and then his genes are going to go on, right? He's going to be fit. So I mean, evolution is happening now. It's not just a past thing. It's happening.
And yet, in our own perception, evolution happened, and then now here we are. And even though intellectually we're aware that both human evolution and cosmos evolution, as you say, is a continuing process, we only can perceive what we can perceive. And so I think in some sense we feel like we look at the past and we grasp it up and we say this is what we've come from. And then we imagine the future.
I mean, in a way, we could say that the early Assyrians who looked at mermaids, to come back to that, they maybe thought that would be a very ideal way to evolve. Not that. I mean, that brings me to my next question. I think a lot of people do seem to think we're not evolving anymore. I think it's a folly of our society to think that we've reached a peak. But of course, biologically and evolutionarily speaking, we are obviously evolving. But the fact that I think it's safe to say that a lot of the factors that have traditionally driven species evolution, like famine, disease, we can sort of control for them a lot more. But what would you say is driving it now?
I mean, I would actually agree that humans are not really evolving.
Really?
I mean, That's not to say that all of the mutations and everything that causes evolution to happen aren't still happening, but with modern medicine, with technology and stuff like this, people that would otherwise maybe be dead because they would not survive in a natural world now have wheelchairs, medicine, a bunch of care, a huge community, and they are otherwise living, and many of them also reproducing, and so you're not weeding out detrimental mutations in the way that it happens with a natural population of animals in the wild. So I would definitely say humans aren't evolving as fast as normal. If we're gonna evolve now, it's gonna be because we're destroying the earth and we have to learn how to live in a radioactive planet, or with less food, or with hotter temperatures. That's where I think the evolution is gonna come in the future.
Right. So what about like societal factors? Do you think we have a very different, the fact that we may have a very different idea of what we would consider a fit individual? I think we should define what fitness is.
Fitness is the ability to
Evolutionary,
reproduce.
the ability to reproduce.
I think one of the problems that society has, and I'm not trying to open up a can of worms here, but it is a can of worms. Yeah, it's actually a oil can size of worms. Is the belief in, well, we as scientists don't believe in creationism, right? We believe in evolution. So, and I think a lot of the misconceptions that people have about evolution and science come from the creationist point of view. And before Darwin, there was Lamarck, there was all these different theories that postulated about evolution, and creation is absolutely one of them. And there's arguments that they say that creationism is right. None of them are correct, but I mean, it's one of those things where the societal factors that affect the way people think about evolution and what humans are doing, or we as humans are doing to this earth, will certainly be the driving forces that shape our evolution, which of course, like I said, we won't be around to see, or maybe we will, I don't know. Hopefully not, there's famine and disease and all that, so.
But we could maybe survive in a radioactive world, that would be
Sure.
cool.
Also, could I just jump in as well, that, I mean, what we're doing with the virtual world is in a sense one line of evolution, that we're sort of modifying ourselves and our brains to be able to take much more enormous amounts of information, to multitask that our bodies do naturally, but to try to make our brains multitask at rates that we never had done before. So a lot of, I think that we're evolving, or trying to evolve, or trying to deal with evolution through computers that we are creating.
I'm sure all of us have felt it. Feeling a little bit efficient in terms of just being able to keep up. Well, you were talking about creationism and how, in my research on Darwin and a bit of his history, he was a creationist for a really long time because that's the world he was born into. And even on his first expedition, as a gentleman explorer, he was still writing constantly about his belief in creationism, and it wasn't until much after that he developed his theory. But one of the effects that his theory and the publication of The Origin of Species had, especially in art, is it kind of really clarified that we were not necessarily made in God's image. It was very humbling. And I think a lot of your work, the fact that you look to these fossils in the ground that are millions of years old, and that's where we came from. And even to go as far back as to our place, our origins in the cosmos. I think it changes the way, or do you think it's changed the way humans have looked at ourselves? Do you think it was a more humbling experience, or was it an empowering one to know that we weren't made in God's image?
I think it's hugely empowering, and it gives you a vehicle, if you think in a different way, for having a great deal of reverence for those who came before us in a way, instead of, if you don't necessarily tend to want to give your spirituality to a God, you may have that same sense of gratitude and reverence for just every part of Earth and every part of all physical things that preceded you. And so to get to know the individuals that
It sounds like
represent.
you had a very personal connection with these.
Yeah, very much so. And so it kind of, when I first started drawing these skulls and people were like, whoa, Sures, you're really into drawing skulls. A death thing or something. And I'm like, no, I mean, I was shocked really by that kind of, by that kind of, humor, because it was like so completely not what was in my head that it just really took me aback. And I think we can really it's not like I'm trying to make them into something that I don't really think they are, but they represent something to me that I know did exist, because I do believe in evolution, proclaim and sacred.
What she said.
I mean, I think there are really two ways you could look at it, because I can imagine that at the time being told one day that you were made in the likeness of a god, and the next that you came from apes, could be very, offensive. But I'm glad that, I agree with you there. Back to the scientists. What are the most common misconceptions about evolution that bug you, really irk you? You see it in art and pop culture, movies.
Well, one misconception is that evolution takes a long time, I think. Certainly, with some organisms it takes longer, but when you think about bacteria, yeast, some of these things that can produce in less than a day and in such huge quantities, there's tons of mutations, and they can adapt to and one of them is going to get a mutation that helps it adapt to a situation very quickly, and it will be able to thrive and go on. Even if you think about, I think Lynn and I were talking about this earlier, if you think about how scientists have driven agriculture, plants, or dog species, how many breeds of dogs we have now. I mean, this was no, genetic modification. Scientists didn't go in and create these dogs. They just selected for a mutation that they liked, and they kept selecting for it to get something that looked, was toy that you could put in your bag versus the wolf that it originally came from. And so in a matter of a couple of 100 years, you can actually see the effects of evolution that have just been sped up because man has selected for that, rather than let nature dictate how fast those traits became fixed. So that's one misconception, that evolution happens over millions of years. It can happen over decades if it gets a little help. And in some cases, even when it's not getting help, but that's probably happening in something very small that you might not be taking note of on a daily basis. Insects, viruses, common cold. Every year there's a new common cold. So that's evolving very quickly.
This
Stuff like
relates
that.
a lot to talk of the post-antibiotic age that I've been reading about a lot, and it's very scary.
Mm.
The fact that the bacteria we're trying to treat with these medicines are evolving pretty damn fast.
Yeah, too fast.
Too fast, very
I guess one of the misconceptions that I always feel like is always there is that understanding evolution is really difficult. I think Brent and I have gone through some examples when we talked about it. It's really not. It's really a straightforward thing. If a form or happens that's advantageous, it will be selected for, pass on its genes, and that's it. That's all it is. I was talking to C that there's another talk at the Museum of Natural History about math and evolution, and we as biologists we should actually be there tonight, right? Because I think we actually yeah. But it's actually not a complicated thing. It's actually a really straightforward thing, and you could see it you turn over a rock and you see an ant that's, has majors, really big workers and really small workers, right, in size, that happen for a reason, right? And it's usually pretty simple. The big ones are there to protect the nest, and the big ones the small ones are inside to tend to the nest, right? I mean, it's something as easy as that. Of course, it happened over time, but that's about it. And the second misconception, just because we already touched on it, is that evolution doesn't exist, right? So it does.
This is sort of more related to function. This was actually a question of Giacomo's, and I really thought of it when Lynn was talking. It's when you were deciding what paper to use, or like how do you approach scientific art and see it? I mean, do you feel like you have to be especially methodical about it? Do you feel like you have to approach it from a scientific point of view, or?
I think that it needs to be clarified that although one is an artist, and that's not something that you decide to be, it's just you are that. You can also be very interested in other things, and hence C's interest in astrophysics and my interest in earth sciences and also some of that too. So your intellectual self is doing things all the time. Your art self is following a process. It doesn't matter what it is that you're making now. So no, I don't suddenly become methodical because I'm working on something that has some relationship to science rather than that I'm inventing a narrative in fantasy that, or making a picture of President Obama. It doesn't matter what I'm doing. Your brain still has to sort of close out other things and do its thing. And that's what happens. So if I choose paper and if I draw a certain way, I shouldn't say this because here I am teaching art and all, but I just do it, and I think that a lot of us can probably say that. You just do it. You learn all the stuff you learn, and then you just do it.
Well, for me also, it's learning it's honing your instrument, it's the practice, the thinking, it's the studying, and then there's also in the process, you're just putting one foot in front of the other, because it's, I just got an email from this company in India that offered to do my paintings for me for a price. And I tried to dialogue with them a little and said, well, part of the reason, part of the doing the work is then you're following a thread, and it's or making a puzzle, or putting together a puzzle, and one step leads to the other, as I'm sure it does in any kind of research.
Evolution.
Exactly.
And I'm sure, coming from, I'm asking this because coming from a more scientific background, everything is methodical. Or is it for you guys? Do you ever, feel that sort of artistic impulse in your own work?
Well,
you don't feel like you have the knowledge, and
You were talking about it.
Yeah.
Too busy repeating everything that doesn't work.
Yeah. We spend our time trying to prove hypotheses are right or wrong, and you get lost in the monotony, but at the same time, you do have to have some artistic side. I guess with presentations and whatnot, I can change the color or tweak a thing here or there, or show a picture from It's always awesome when you're a scientist, you show a picture from 1900s, you're like, yes, I put it in, my modern day. Everyone thinks you're like, brilliant guy. But no, it's you try to throw it in some way, shape, or form because it's it's like Brent said, it's monotony. That's basically what it is.
We get lost in monotony too.
Sure.
That's actually what we do best and most.
So.
Every process is endless and tedious, and that's how you get what you want to get. In the same way, I presume that
Sure.
you all
Absolutely.
experience.
Yeah, we're watching Greg, my husband, work, who's a scientist, I mean, it's a very, very parallel process. And he'll go through whatever he's going through and reading and research and thinking and writing down straight things, and then all of a sudden it'll sort of coalesce and come together, and that's the process that I go through. And as you said, the tedium, the doing what you have to do, and then all of a sudden it starts to form.
And there's also the enormous component of uncertainty. When you say it all of a sudden coalesces, before it coalesces, you're wondering what in the world you think you're doing, and what would anyone else think if they saw what you were doing. So, and then it coalesces.
Not unlike evolution. Okay, the last question I'm going to open up to you guys is, I mentioned earlier that one of the things, this is what I get irked about, when people, it's something that people get wrong about evolution. It's the idea that evolution has a goal, that we're evolving towards some peak humanity. But the reality is there is no purpose to evolution, it's just a process. Right, could you maybe explain this to us in a more scientific way?
Sure. So there's landscapes, right? There's region. There's things that happen in time and space, and famines and disease and all these things that happen. So there really is there is no such thing as a de-evolution. It's an evolution for something else to happen, right? And we're plastic enough for, as Brent was saying, bacteria that have these really, really fast life cycles that they can evolve really, really quickly. We, on the other hand, may evolve a little bit slower. But yeah, there is no end game. I mean, take the meteor that hit the Earth and all the dinosaurs died and mammals came out, right? Mammals originally were not the land-dominating species that we are now, right? It was dinosaurs, reptiles, as Brent was saying. But there was this thing that happened, and mammals decided to hang around. They got lucky, and they evolved. And they evolved into what we're doing right now. So yeah, it's there is no end game in it, and it's like we've been saying. The theme is it keeps on going. Always keeps on going.
Yeah, to assume that there's an end game would be to assume that at some point DNA stops mutating, and that that everything on the planet becomes fixed environmentally, the way people live, just static population growth. Everything would have to stop moving, basically, and that's just obviously impossible. So yeah, so yeah, an evolutionary endgame is just as impossible.
I would like to open up the floor to our audience. I'm sure you guys have a lot of questions.
Quick question. You mentioned evolution in time. Through my own evolution, I've kind of come to believe that time actually doesn't exist. What do you think about that?
Brent?
Time is actually a pretty difficult thing to pin down, right? I mean, as a matter of fact, there was just a competition to see if anybody could describe what time was to a child. And I didn't see the outcome of that competition, but just the amount of ways that you could approach it from are mind-blowing. And just recently, somebody released a paper that basically said, yes, time doesn't really exist, but events move in a certain direction, and that has to do with entropy in the universe. And so that means that you're not going to get a cup of coffee spontaneously heating up, or a building constructing itself from ruins. And this all has to do with quantum entanglement. I guess when the coffee cools down, the molecules entangle with the air molecules, and they can't become untangled, so it doesn't go the other direction. That's all I have to say about time. And as far as your evolution in time, I don't know what to say about that.
I'm interested in knowing how you got to this conclusion.
Oh, wow, that's a long one. There's no time
It was
for
a
that.
pretty bold statement.
Just a lot of thought and pondering of my own evolution, just life That's basically. I mean, obviously I can go into a lot more detail, but yeah.
And as scientists, we would probably say that you as a person are not evolving. It's possible.
Yeah.
Not to say that you couldn't get a genetic mutation after you were born that wasn't introduced at birth that you could then pass on. But sort of how scientists think about it, sort of however you're born, you're going to pass that on or not, and then evolution is going to have to happen generationally versus within a single.
But I actually kind of like that. You know, because it makes sense. No, seriously, it really does make sense for me. Personally, it makes sense. Yeah, it's kind of cool.
Okay, so right here.
So this is to both the scientists and the artists. But to make art about something, especially something like evolution, you kind of have to have a knowledge of the nature of it. You have to have some kind of ability to say, what is this process? What's going on in it? And the nature of evolution itself changes, and has changed through time as we come to understand it better. And both of the two artists have presented relatively hopeful visions through their art about how evolution connects us. But evolution as a theory has gone through some phases which have been pretty dark. And I'm talking about, say, replicator phenotype theories, or like the idea that phenotypes are essentially just vehicles for genes, and genes are really the thing that's evolving. And so there have been kind of this dark nature to evolution, as well as maybe a lighter nature, such as the advancement of complexity, or the growth of altruism, or something like that. And that's changed just in the last 100 years. You've seen shifts within evolutionary theory between these two kinds of along the spectrum. I'm just wondering, do you think that as we come to understand evolution better, could it kind of turn into something in which you can make really, really good or interesting art about, or is it kind of inherently in its basic aspect because of the moth with the cross through it, right? It's because its basic aspect is just not something that's really amenable to art.
I should actually make a point. If anyone has a chance to read Darwin's memoirs to his wife, where he spends a lot of his time coming to grips with his theory and how it's actually not a great theory, right? It's not hopeful as religion was at the time, right? I mean, you don't end up in heaven, right? If you're not strong enough, if you're not fit enough, you die. And I wouldn't say that it's dark or light. I mean, we view it as scientists as just evolution. That's all it is. It's as gray as it possibly can be. Yeah, I don't know.
I think you guys comment
Yeah.
further on.
We'll review it in art.
I mean, I err on the side of, even though my husband describes me as a dour Scandinavian, I feel like in my work I err on the side of optimism, and particularly with the idea of consciousness, which is why I really enjoy dialogues with scientists, because it gets me thinking along other lines. And I mean, I do believe that humankind is evolving towards a more hopeful future, and that's not a biological evolution. Although biology is going to have to actually play a part if we, in fact, are going to go. If we're going to deal with what we're going to have to deal with, in my point of view, climate change, getting off this planet, being able to become a starfaring civilization. So from that point of view, I choose to become hopeful. So I choose to do art that way.
I don't feel at all invested in the whether it's hopeful or not hopeful. I just have this huge curiosity that I'm trying to satisfy, trying to answer my questions, trying to think about my own personal definition of what humanity is, and the different contributing factors have played a part in it. And so, I wouldn't be at all put off if something really gruesome came about. It's just, right now, it is that reflection.
I was struck by the drawings of the skulls and how much each skull was individual and had a real personality and character. And if I had the opportunity to look at each piece longer, I would be able to know that person. They're wonderful.
Thanks.
I'm speaking as an artist, I'm not a scientist. And I do a lot of portraits and work about people and humanity, and they're great. I mean, those skulls were just like, wow, I know that person. I don't know that person. that was a very individual, particular person with a personality.
I feel that way too as soon as I look at the castings that I look at. And I've noticed that on the rare occasions when I get to see the real fossil rather than a casting, that it's enormously much deepened. And I would do anything to get more opportunities to look at real fossils. I haven't ever looked at any of the ones that they have here in New York because I'm from DC and I have had my opportunities there, but if anybody knows natural history here, I'm on it.
Good luck.
Right here.
I was curious about scientists and artists in terms of that moment of eureka in science and perhaps that moment of inspiration in art versus kind of the rhythm and the pattern of process when there's this change in the current, and literally it could be like an electric current that gives you that eureka. If you could kind of talk about that in terms of how things evolve and change.
You had a eureka moment.
I mean, I think the eureka moment might be a little overstated, but you definitely have moments where you'll get a result that actually moves the project that you're working on forward, and because it's very few and far between, it feels real good. Amps up your motivation to keep working, and it also completely redirects your work because gives you new avenues and new experiments to do based on that result to try to prove it, or now you're going to work something else into the puzzle, right? So it feels good. I mean, I think anybody would say that. It probably feels good.
I mean, I find myself in the midst of it now.
Congratulations.
I'm very deep into it. Well, I think I'm very deep into my PhD, and I'm trying to finish up. But I'm spending a lot of time troubleshooting, going through the monotony. Actually, when you guys were talking about just the rigor, just as you were saying, of doing something, and the second you finally start getting results on anything starts working. I wouldn't call it an electric current, but I would call it something that's damn near close. It's something that kind of like, oh, wow, I'm actually doing something, and I can see it working. And I don't know if you can relate that back to the canvases and your pictures and all that. Sure.
Well, for me, I tend to work slowly and methodically and ploddingly, and as it starts to, as the picture starts to come into being, or as the idea comes into being through the picture, through moving the picture, or through the process of figuring out how to have something work, how to put together something. It all becomes part of the weaving of able to see, instead of the individual pieces of threads, to start to see the whole cloth in essence.
I think I might have reverse eurekas, because, no, because first I'm just doing, well, it's great to have the idea of what you want to do, but that's, I think, probably more equivalent to having a hypothesis. Okay, so, you know, you do and you do and you do, and I try really hard not to judge what I'm doing while I'm doing it, because I try not to create impediments for myself. So it's usually kind of looking back and going, oh, wow, I can't believe I did that, rather than, oh boy, I think I'm onto something. I mean, I'm not gonna say that there's absolutely no emotion at all, but it's more that I'm so kind of focused on the discovery itself that I'm, you know, which is each work that you do is an unknown, and it's not planned out perfectly, or in my case, hardly at all. And so when it's, you know, the whole time you're seeing that this is what you're doing. Oh, this is what I'm doing, and now I'm doing that. and so the eureka, I think, comes at the end of either a work or more likely a series of work.
Have you got any other questions? Okay, awesome.
I would like to make one comment on what you said about speed of the evolution. It's I know about two scientists, unfortunately I don't remember their names, who went to Galapagos Islands, and there was just two summers that were too dry, and females, finch females, start to choose particular males that whose finches were adapted to more dry weather. And just during 2 summers, the beak of the finches on this particular island changed. So it's not necessary that humans invest something like dogs' mutations or whatever. But last several years, I heard several times about epigenetics, that the scientists discovered that not only genetics define how we develop, but also how we raised, and what the social structure, and what the, could you say something more about it, something more about epigenetics, not about genetics and mutations, how it define our evolution also.
So if I may just define epigenetics real quick.
Okay.
Basically, it's epi meaning above, genetics above the genes. So all changes that are happening are not to the DNA itself, but to proteins that interact with the DNA and all that, right? So modifications to the DNA, not physical change.
Regulations of the genome.
So as it turns out, this is a real phenomenon. And what a lot of people, actually just a talk I just attended last week about, it's called transgenerational inheritance. And what you can see is that if something happens in the adult, it can be passed on. So it's a very hot field right now that people are still trying to understand. The only thing I can basically tell you, because I'm not an expert in it at all, I know that it's real and it does happen, and epigenetics are real. So there is a whole nother linchpin in this whole evolutionary process, which is epigenetics. And you don't have to have something that changed specifically to a gene. You can have something, as Brent was saying, regulatory, where the gene's expressed at a certain place at a certain time, and all that can have a great effect. I don't know if Brent has anything more.
I don't have much to say on it, except for there's not much known, as Giacomo was saying, and so I think the jury's still out.
Sure.
For sure, as to whether this will actually fold itself into theory. You know, anytime you're looking at humans, and doing studies in humans is very difficult, looking at evolution of humans, because humans mix a lot when we reproduce, right? a lot of times when people want to look at the genetics or the evolution of human populations, they have to find some tribe that hasn't seen the outside world for a few hundred years, and they've just reproduced within. And this is the easiest way to look at it. Unfortunately, this doesn't really exist too much anymore. So doing stuff like these epigenetic studies and stuff like this, it's difficult, and it'll be interesting to see how it pans out. But I don't know much about it right now. So, but yeah, it's nice that you brought that up. It's an interesting point.